Hi everybody, hope you are all well and healthy. My name is Aline and I will present to you today a study developed by me and two other researchers, Professor Gizzi and João Vitor, entitled Finding Patterns of Openings Operation and the Influence on the Thermal Performance of Houses. This is a case study in southern Brazil. User behavior regarding opening and closing windows is one of the factors that most impact the performance of houses. Several studies applied computer simulations to assess the impact of energy efficiency measures even before they are implemented. And in order to avoid inconsistent results, it's important to use real data and to take the variability of user behavior into account, which lead us to apply more than one user profile in simulations. One way of doing so is to use some data mining techniques such as cluster analysis. Within this context, this study aimed to obtain different user profiles regarding openings operation based on actual data and analyze their influence on the energy performance of buildings. The method applied in this research consists of three steps. First, data regarding openings schedules were collected in single-family low-income housing in southern Brazil. Data were collected for living room and bedrooms, and they were organized in binary hourly basis, resulting in 24 intervals. Then, data were submitted to cluster analysis, which combined hierarchical and non-hierarchical procedures. The reference models for each cluster were defined as the closest object to the centroid of its cluster and described by an hourly schedule representing the time of the day doors and windows remained open. Finally, computer simulations were performed with Energy Plus. Natural ventilation availability was configured according to each reference model's operation schedule. All other parameters were kept constant. Two indicators, air change rate and sensible heat gains and losses, were obtained in order to verify the impact that different users' profiles have on the building performance. Cluster analysis resulted in four distinct groups, each of them represented by a reference model. Here in this figure, it shows when and for how long each opening was open. The horizontal axis shows the time of the day, 24 hours of the day, and on vertical axis we have the name of the openings, door 1, door 2, windows 1, window 2, etc. The circles filled with colors represent the hour of the day in which each opening remained open. For example, reference 1 has all windows and doors open from 10 a.m. to 6 p.m. One can observe from this figure that reference models are quite different regarding their opening schedules, which already give us a clue that their variability may lead to a different thermal performance. This is confirmed by the results obtained from simulations. Here in this figure we can see the air change rate obtained from each reference model. The red lines represent sensible heating gains, while the blue ones the sensible heating losses. In order to summarize, only results obtained for the living room are shown. It's possible to observe that the air change rate differs from each reference model and occurs accordingly to their opening schedule. The most expressive air changes were observed in the cold seasons for reference models 1 and 3, and in the hot season for reference model 2. Differences in their schedule can influence the performance of a building, which highlights the need to consider user variability in thermal and energy simulations. Finally, this figure shows a summary of monthly sensible heat gains and losses throughout the year for all reference models. Reference model 4, which openings remain open for the longest period, showed greater sensitivity to the effect of air infiltration, as it had the highest gains in hot season and high losses in the cold season. Reference model 2 suffered the greatest heat loss in both winter and summer. This reference model internal doors remain open for a longer period, which influences the performance of models by allowing cross ventilation. The opening schedules of internal doors are usually not taken into account in most studies, being configured as closed for the whole period. In this study, however, a difference related to the opening of internal doors in the performance of the buildings was observed, from which the importance of taking them into account in computer simulation is verified. At the end of the study, it was found that cluster analysis is a suitable method to obtain reference models. Four different reference models were found representing the variability of occupant behavior, and the influence that different schedules have on thermal performance was confirmed. It was possible to conclude that the use of more than one reference model may lead to more reliable performance indicators. This study also highlighted the importance to determine operating schedules for internal doors, which is usually neglected in thermal performance studies. Here we have some references mentioned during this presentation. And that's it. Thank you all. It was a pleasure for us to share with you our findings, and we hope this study have reached your expectations. Please feel welcome to contact us for any doubts or comments you may have regarding this study.